Hello everyone. Good morning to all those who are attending us today from India. And so today we are going to start with our session, and it's going to be really amazing because we have a really amazing speaker. Uh, Before I introduce about her, I'll just quickly run you through what this community is about. So we have been doing so many meetups in this community, which is Azure Developer Community, and we have currently crossed 6,000 members already. So let me just quickly run through what are we doing in this community and why are we doing this. So as you can see, Azure Developer Community started with these three basic ideas. So we are here to help everyone to learn on different technologies by sharing ideas and giving them a platform to learn on different things. Also, as we know, in a community, it's always a very big opportunity to network with others. So yes, we have so many experts in this community. We have so many different organizers, speakers, and mentors with whom you can network and grow. Also, we are giving the platform to all the experienced people who have something to share with the community so that they can get upskilled and grow with us. Currently, we have already crossed 6,000 members within a span of just 3 to 4 months. We started this community on 26th of January, and currently here we are. So we have already 6,217 members, and we are across 100 plus cities. So we are not just touching cities which are just the high-tech cities, but also we are touching upon the two tiers and three tier cities. And our organizers have been running so many events, these are the upcoming events which we have under the banner of Azure Developer Community. As you can see today, we have Mamta Jha with us for this session. So if you haven't joined any of our communities, you can just directly search for your nearest community and join them so that you get regular notification about the events that are happening near to you. Also, we have so many partnering communities for whom we are really thankful. So they are partnering with us to spread the word about the events that we are doing, and we are collaborating together. So these are the set of community organizers we have who are helping us spread the word across and who are organizing these events regularly in their communities. Also, we have recently launched Speakers Bureau. So this Speakers Bureau basically will help all of you to get connected with these experts who are ready to spread the word across and share knowledge within the community. So we have a great list of Speakers Bureau already. So you can visit the website and check across. So that is all I just wanted to run you through. And so today we have Mamta Jha from Test Scalable, and she is going to give a wonderful session on Python on Azure. So I'll bring her on board, and she can tell you what she is bringing on plate for all of you. Hello, Mamta.
Hey, hi, Rohit. Hello, everyone. Hope you people are doing safe.
So, Mamta, we are really grateful to have you today. So, this is the first time you have joined us here in this Azure Developer Community, and we have so many people who have joined from various places in India. So, you can tell us like what is today's session going to be about, and what are the things do we have?
Sure. Today's session is about deploying Python application to Azure Kubernetes cluster, but we would be automating the entire stuff of creating Python-based containerized application image using Azure DevOps, and we would be deploying our application to AKS Cluster in an automated fashion. So We plan to use all the tools which are being depicted on the right side and their icons like Docker, Kubernetes, AKS, Azure DevOps, and certainly Azure Platform. We would be using a few other services like Azure Container Registry to integrate and push our images and keep our images in that. A brief introduction about myself. I'm Mamta Jha. I head a company called as Tech Scalable. I'm having around 17 plus years of experience. I belong to Orissa. Like I have born and brought up in Orissa. I've done my engineering from Orissa, and I'm married to a Oriya family. So when Rohit approached me for this particular session, I immediately told yes, looking at Bhubaneswar, because that's obviously very close to my heart. And from the time I came to Bangalore, I started working. I've worked on quite a few number of stuffs. I started my journey as a C developer and then moved on to all the three clouds. Initially started with OpenStack, but that didn't capture that much of market in India. So moved to public cloud. And majorly these days, doing automation, containerizing application, running them in Kubernetes is what something we love to do. So we will start with today's session. So we are planning to use Python. We would be containerizing the application. We would be deploying that in Kubernetes cluster, but that Kubernetes cluster would be from Azure. We would be using Azure's Kubernetes service. We would be using Azure's container registry, and we would be using Azure's DevOps tool, which would have Azure Repos and Azure Pipeline. So we would write a YAML pipeline, which will do a automated integration and automated deployment. I have not pre-cooked several things and kept it. Normally we pre-cook for the demo and keep it, but I have not done that. Why? Because I want to deploy everything from scratch. So I just have a virtual machine running in which I have done nothing apart from my code, which is residing here in this folder.
Mamta, in case if you are sharing a screen, we are not able to see
Oh,
because you haven't been able to share
sorry.
it.
Yeah.
Yep.
So I was showing the pictures as well. You people missed this. Sorry for that. So
Yeah,
this is our
don't worry.
agenda. Yeah. Yeah. So this is the server. It's a plain Azure
Sorry,
Ubuntu
Mamta, but
machine.
we are able to see that stream your screen, not your screen.
Is that so?
Yeah.
Just a
You
minute.
can minimize that one.
No, that is not on my actual window. What do you see now, Rohit? Don't you see my
Yeah, we
screen?
can. Yes, we are able to see your screen, but it's not full.
Okay,
Right.
then I think you're not seeing the actual screen, you're seeing the extended screen. So let me get that here. It is not given an option to two monitors. It's not allowing me to select. Okay. Now tell me if you can see my terminal,
Yes, I can see that.
correct? Okay.
Yes, now it's fine.
Yeah. Cool. So this is a Ubuntu-based machine, Ubuntu 18.04. I have done nothing. I have just executed apt update and I've installed apt. I've installed Docker with apt install command, nothing else. And I'm sitting and developing my code over here. So we would be using our Python application. We would be like, as a developer, we sit and create the Python application in our workstation. So you can see that I've named my Ubuntu machine as a my workstation as well, right? So this is the file, and this is my app.py file, which actually does nothing much rather than serve this index.html page. And index.html page is, I think, ls, it's in templates. cd templates index.html. I'll just cap that index.html file for you people. So when we open the web page, it will say, Namaskar Bhuvneshwar, we have automated all these stuffs using these tools and keep learning. That's my message for you people. Now, if I have an application like this, how do I work with it? So I first need to containerize my application. So we will go step by step. I'll just move this guy the other side. Okay, cool. So we would go step by step, like we would have application. I have my app.py and I have my supporting index.html template. So this is my Python app. This application can run anywhere, right? I can deploy that on a virtual machine as well, but I don't want to do that. I want to containerize. Containerize in the sense I want to run that in a container. For that, I will have to prepare a containers image. That means I need to put this application inside the image of a container. For that, we do quite a few number of stuffs, like I can first create a Docker file. Docker file is used to create Docker images. So I write a Docker file for a application. So you can think that my Python application is a microservice-based application. For that, I will write a Docker file. Docker file will execute with a build command, and we would produce an output, which would be nothing but a Docker image. So I'll first do things manually, and then I'll show the automation part of it, because unless and until you do anything manually, you will not be able to know how to automate that, right? So we will first do things manually. I have a virtual machine in which my code is residing. So you can think this is the VM in which your code is residing. I can consider this entire stuff as my virtual machine. I have my code written in it. And now I need to have a Docker file with which I can containerize my application into a Docker image. I would manually run Docker container on my system. So I can deploy a container on a virtual machine. I would use Docker run -d command because I want to run my container as a background process. And I would expose some specific port number on the host machine where I can reach this application when it is running as a container. So I'll tell you a little bit about the containers networking as well that time. And my containers application is expected to listen on port number 5000, and whichever image I produce with the Docker build, I would be providing that. So this would be the first step we would do. So let's do this and then move on to the next particular step. So if you go back on this folder, you should have your Docker file residing here. I'll just cap that Docker file for you people and let's discuss what exactly it is. So a container always comes up with a base image. Base image provides us the operating system on top of which you want to actually deploy your application. So I'm starting my container with a base image of Alpine 3.5. Alpine is a very thin layer of operating system from Linux family itself, but it is very thin compared to Ubuntu and other OSs. I'm installing Python pip package. I'm going ahead and copying a file. So copy command copies a file from the host machine. If you can see, I have requirements.file text file over here. Let me parallelly cat that as well. So in requirements.txt file, I will write all the packages I need. Today, maybe I need just one single package to be deployed, but it could be that I'm needing multiple packages to be deployed. Instead of writing this command several times, I would just go ahead and write once the pip install command and provide this text file in which I would have listed all my packages. With that, what would happen? It would recursively go and install all the softwares which are needed. And that would happen because we have given -r. -r stands for recursive. Recursively install whatever is needed, whatever is mentioned in requirements.txt. That's the intention behind writing this line. I'm copying my code file, which is app.py. I'm copying my index file as well. So index file is copied in source, user source app inside the container, and index file is copied inside the templates folder. This particular statement just mentions, it's like a metadata to inform the user of the image that when you are actually going ahead and deploying a container from it, then you would be exposing port number 5000 for your container application. Like you see here, why did I mention 5000? On the host machine, I can pick up any free empty port and I can mention that on the first parameter, which I have left blank, like here. But 5000 is a constant port number because my application is made to listen on port number 5000. So I would not be able to change that because my application is made that way. And that's a reason we are specifying it over here so that if someone is using an image created out of this Docker file, then the person knows that 5000 is the port number which would be used. Now, the last statement in the Docker file normally specifies, it's not necessary that it's the last instruction in the Docker file. The CMD instruction in the Docker file says what would be the process which would be running inside the container once you start the container. So I'm saying that once the container starts, my app.py would get executed. So I'll just verify Docker command is working. Yes, Docker is installed. Docker command is working. Installing Docker is pretty simple. You can just do sudo apt. I'll just type in, but I've already done this, docker.io, and give -y at the end. You would be able to install with this. And after this, I should be able to build my Docker file and produce an image. Docker build command picks up the Docker file, and you would see here that step-by-step execution of all the statements are happening. And at the end, my entire Docker file would get executed, and whatever, like I had asked to install Flask, I had got to copy the index file, I've copied the app.py, everything is done, and it has produced this particular image. So this is the image which is produced. You can execute Docker images command to list the images. You can find here, there is this image ID matches the image ID which is being produced. But strange, there is no name for it. That is because in the Docker build statement, I have not given a tag for it. I can even tag that with the Docker tag command. I will give the ID and you can specify a name for it. A name like my Python app, for example. And I'll give the version as latest. So this is the image which I have produced. Now, image is produced. Let's see whether my application actually runs inside a container or not. Then I'll plan to deploy that in a Kubernetes environment. So for that, we would execute the Docker run command. Docker run command creates and starts a container. I'm planning to start the container as a background process. So I give -d in it. D stands for detached mode, or you can say as a background process. So -d, I have to give -p number. In this host machine, I have opened all the port numbers, but obviously that's not safe. Let me give port number 5000 for the host machine and port number 5000 on the container. So first parameter stands for host, second parameter stands for container. I can even give this way. I can say 80:5000, then also this would work. We just need to make sure that container packet would get forwarded in a proper way. So how does this work? Let's try and understand that as well. So at present, what we are planning to do, I'm just trying to explain that. Hope that makes sense for you people. So this is my virtual machine, which is running in Azure. And it has obviously an Ethernet interface 0 from where I have SSH on this machine. This is that Ethernet interface 0. And I plan to run container inside that. So there is a bridge which gets created as soon as Docker starts running in that system. This bridge is there on the Linux level as well. You can list the Linux bridge too with brctl show command. On the Docker level, this bridge is called as bridge. But on the Linux level, the bridge is called as Docker 0. So whenever we create a container, in the default bridge network that gets hosted over here. Now, when I execute a Docker run command, a container C1 would come up and would grab an IP address from the subnet range of the bridge and would be up and running. This guy is listening on 5000 port number. But remember that container would always get a private IP address. A private IP address is not accessible from outside. But when I want to reach my application from outside, what do? I grab a port number on the host machine and I say that this container would be attached to this particular port number on the host. In the world of Docker, it is called as port mapping. I'm mapping a port on the host, or publishing a port, also people call it as. A host port would be tagged to one container's port. So what happens if you do write this -p 80:5000 or -p 5000:5000? Exactly what is happening at the back end. As soon as you do that, a IP table rule gets written here that whenever a packet arrives on VM's IP address on, for example, I have written port number 80 and container's port is anyways 5000, then accept the packet on port number 80 and then forward that to the bridge, and bridge will forward that to container's IP address on container's port number. That's the reason we would be reaching the container if we are reaching this. So like this, it would be. As soon as the packet arrives here, a user sitting here would access our application. Then that person would be reaching on port number 80, would directly reach to our container. So we plan to do this. Let's see if we succeed in doing that. So I need to specify the image with which I want to bring up my container. Let's start. To confirm my container is running, Docker PS command, yes, container is up and running, port number 80. Let me grab the IP address of my virtual machine. And let's go and access. I think I picked up the correct one, my workstation. So yes, so you see this welcome message that is serving from within my container. I'm not hosting anything on my host machine on port 80. I'm hosting a container on 80 port number on the host machine. So this is looking good. Our application is running. Container is created successfully. Now it's time to set up our AKS cluster and a container registry and all that. So let's understand that part as well. Hopefully this part is clear. Now, Rohit, if there are any questions, where do I see that? In the comment section? Okay.
Yes, if you're able to access that comment section, you can see.
Yeah, okay, sure. So now we have our workstation. I'll just draw the workstation a little bit smaller this time. because I need to draw a few other stuffs. I'll draw my Azure Cloud account here. Okay. This, let me pick up a different color for it. So this would be my Azure Cloud account. In this Azure Cloud account, I wish to create a AKS cluster. So this is my Azure account, not Azure DevOps, Azure Cloud. And this is a workstation. This workstation can be my laptop as well. Okay. This workstation can be my laptop. My code is residing here. I have installed Azure CLI in this so that I can interact with my Azure Cloud account. But I've not configured that because I wanted to show that to you people, how to configure it. So Azure CLI tool is installed, but it can't talk to my Azure Cloud account first. You can create your AKS cluster from the CLI. You can create your AKS cluster from the portal. I'm going to create from the portal the AKS cluster. So my AKS cluster would be residing here in my Azure Cloud account. Let me try to draw a small cluster. And I would have two nodes in that cluster. One would be my worker node 1 and one would be my worker node 2. I plan to deploy my application over here. Yeah, if you guys need the GitHub link of mine, 1 second, hold on. I think my project is accessible. Rohit, I'm posting a message. I'm not sure if others would be getting it. So if they don't get it, can you just post that to them?
Sure, ma'am.
That's my link, and it's a public project, so I think you should be able to access it. In case you're not, just let me know. So I have worker 1 and worker 2. I'll go ahead and create a worker 1 and worker 2 on my AKS cluster. I need to create another component where I would be pushing my image. Understand that at present, Docker is residing here. I have OS, I have Docker, and I have executed the Docker build command, and I have created image, and that is residing in the file system of the server. But I can't share with anyone else unless and until I push that into a central location, right? So this central location would be my Azure Container Registry. So I'll create a private registry here. And in that, I will keep my Python app image so that on the fly, when Kubernetes cluster needs that image to pull and deploy the container, that should be done. Okay. So let's first create a AKS cluster and our Azure Container Registry. Both we will do it together. So Kubernetes service, if you're not finding that on the top because you have not used it, just type Kubernetes on the top and you should be able to see Kubernetes service as one of the options. So Kubernetes service I'm selecting. On the left-hand side, it has a create a cluster option. Let's go ahead and create a cluster. Just minimize the size. So in Azure, all the resources are segregated or grouped inside a resource group. So it's asking me to create a new resource group, or if I have an existing resource group, I can do that. Advantage of creating a resource group is that when I want to delete anything, I can delete that in one shot. So let me check if I have an AKS demo resource group. I can select that. It's very simple to create. Just write a name. If it is syntactically correct, Azure accepts that name, then you can press OK. I already have one. I've selected that. Give a cluster name. Cluster name is AKS demo. Okay. I am selecting East US2 region. in US. And availability zones. What availability zones say that if I'm creating multiple servers in my AKS cluster, like a worker node 1, worker node 2, worker node 3, whether all of the servers would be residing in one zone or I would spread them across the different zones. So I've chosen all to spread across all the 3 zones. Now, version of Kubernetes, which I've picked up, is the default version. We prefer to go with this because that's well tested and all. So 1.19. I would change the size of the machine. You can go with B2S, 2 virtual CPU, 4 GB RAM is the minimum size needed. So I'm just selecting that. Scaling option, manual scale or auto scale. We know that a cluster can auto scale on demand. If I want to do that, I can click on auto scale and I can say start with 2 servers. And when load increases, max to max go to 5. So these are few of the options. And after that, you can keep going to the next tab and updating each of the parameters. Now, if we see, our AKS cluster can have different sizes of the machines. Like, for example, I can have 5 machines of 2 virtual CPU, 4 GB RAM. I can have 3 machines of 8 virtual CPU, 16 GB RAM. How do I specify that? They are segregated in agent pools. A pool would have similar size of nodes. So I'm having B2S size of nodes and they are in 3 count. If I want to add more, I can add it from here. I can choose what would be the size and all that from here. So I'm not doing that. I would just live with 3 node cluster and I'm not going to change. I'm just skipping few of the stuffs over here, like virtual node, VM scale set, and all that stuff. Authentication mechanism. Normally, when we are having authentication across services, like my Azure Kubernetes service would interact with other cloud services of Azure itself, there would be authentication, right? Now, AKS will go and pull the image from ACR. Why will ACR allow to do that? So there should be a authentication success, and then only that would happen. So we are going with this. Same way inside Kubernetes, you have role-based access control. Like, for example, I can say I'm creating a cluster. Mamta is an administrator. She can do anything on the cluster. And Rohit is a developer and limit his access on the cluster. Or I can say Venkateshwar or Sumit belong to the test team. They can do just certain piece of action in the cluster. That's the reason I'm just enabling that. We might not be utilizing that. Now, the nodes would have disks. The encryption of the disk would be chosen this. I go to the networking section. I can use Azure CNI or I can use Kubernetes default networking. Azure's CNI, this is the virtual network VNet of Azure, which would get created and it would have subnet. I can define the bridge IP address for Docker. I can define the service ranges for Kubernetes. I have the liberty of doing that over here. So I'm choosing that. I already have a standard load balancer, the normal load balancer, Azure load balancer, the network layer 4 load balancer integrated with my AKS. We normally switch on our Calico's network policy or any Azure network policy. This would help us in limiting the stuffs like I don't want 2 pods to communicate with each other, then I can limit them later by applying some policies on them, saying that pod 1 can't talk to pod 2, or pod 2 can't talk to the outside world, that sort of stuff. So I'm just incorporating that as well. In the integration section, I'll go ahead and create a container registry. Let me quickly create from here. A create button is given. Registry name got to be unique across Azure because it has a DNS name associated to it. So I'll say AKS demo, and I would give, say, MJ. It will belong to the same resource group. It would be in the same region. I am enabling admin user access so that when I want to do a login, and push my Docker images, I can do that. I'll get a password over there. And here I would go ahead and press OK. So these are the parameters for my container registry. I'm disabling container monitoring because we are not using it and that charges heavily. So if you're just trying it for test purpose, just make sure if you're using a pay-as-you-go account, it's good that you disable that container insights. It's a little bit costly service now, but it does a lot of stuff and that's the reason it's costly. Yes. So Azure creates a load balancer, Tejaswini, and Tejaswi, sorry, Tejaswi Tanmaya. Okay. So Azure creates a load balancer and our virtual machines which are there, that would be behind that. That is the one which is already integrated. And tomorrow when I want to expose my application, a Python application, when I deploy, I want to expose it to the outside world. I would be exposing it with a service type load balancer that time. I can directly create a load balancer in Azure if I have integrated that. And that was, these days it is by default, you don't have a choice. So your AKS can talk to your Azure Load Balancer service by default. So these are the parameters which we have chosen. Validation has passed. We would hit on create and we will have to wait for some time. Cluster creation nearly takes 5 to 7 minutes. It would bring two things. It will bring a AKS cluster and it would bring a Azure Container Registry. So we would have this in some time. It will take a bit of time. So meantime, let's go and authenticate our virtual machine with our Azure account as well. So AZ login is the command to log into your Azure account. I'm not sure if you people are able to see this yellow message. It asks you to go to a page on the web browser and enter a code which is being specified here. So I'll pick up this and I would go to the browser. And here I need to enter that code which has been prompted. So let me quickly get that and mark next. It would ask me to sign in. Let's choose the account and I would say continue. So authentication is successful. Let's go back and see. In some amount of time, you should get a prompt back over here. But the prompt would come with all your Azure account details. I have multiple subscription. You would see a lot of them gets listed over here. Now, in which subscription I would be doing the action, that needs to be pretty clear because I have multiple of them. So what we would do, I would set as your set, there is one command to list the account list as well. That will also give the list of the subscriptions which are there in my account. Account list. Oh, there was a typo in account. Sorry. So this would list. And now Azure set Azure account set -- subscription. When you work on several clouds, right? Many a times your brain doesn't work. With respect to what is the command you got to enter now, I was like a bit skeptical in typing that command now. Just hold on. I want to work with the subscription. So let me just choose that and see whether I have correctly written. Awesome. So it's not AZ account set, rather it is AZ account set and you give the subscription ID. So now I am in my Azure subscription in which I want to actually execute my command. My system is now configured to talk to my Azure account. Now let's go back and check the status. This guy is up, not yet. It's still in progress. So when it comes up, it should be here, like it is still. Remember that cluster is a managed cluster, so it would be doing all the stuffs and getting a ready-made ready to use cluster for you, right? So in that case, a lot of things like installation of OS, Docker, Kubernetes, creating the cluster, joining the cluster, so many things are happening at the back end, which we are not doing it, certainly, because it's a managed service. That's the reason it is taking some amount of time. Let's leave that peacefully and see if our container registry is created. So container registry, if you just type container, you can find that in the dropdown. Go and check. Yes, this guy is created. AKS demo MJ is the name. And this is the login details of it. So I'll just show you how to access it. So just type admin over here. You should get the access keys. I need to push the image in an automated fashion, no doubt in it. But I mentioned that we will do stuffs manually and then automate it. So I will manually push the image to my ACR. I will manually deploy my application to AKS Cluster, and then the hero of the session, which is Azure DevOps, will come into picture. So this is my username for this. Let's go back to this system. Let me do, sorry, it's not ACR login. And I need to specify the parameter with -n. I would give the name. The name is of the Azure Container Registry. I think I've picked up the username, right? Let me pick up the name of my Azure Container Registry first. That is also the same. So, yep, I think, yes, correct. So that is all the same. It would prompt me for a username password. Here it has succeeded because my AZ credentials are already been configured. If my AZ credentials are not configured, then it would have surely asked. But at present, it's configured, so it is immediately getting it, and it says logging is succeeded. Now my Docker images are residing here. I can't literally push this image like this. You can't. Why? Because to push an image to a registry server, the naming has to be proper. What is the naming which we have to provide? Let's discuss that. Let me get my writing pad. So the name of the image is always registry/repo::tag. This is my ACR name. This is my Python app, the name of the image which you want to give. And this would be the version, say version 1. Now, every day I'm building an image and producing an image and pushing that, then this first two parameters would remain the same. I would just keep changing the version from version 1, version 2, version 3. Like you have various software releases, Nginx version 1.17, 1.20, 1.19, 1.21, that sort of stuff. Okay. Now, my intention is to tag the image in a proper way so that I can push that to my Azure Container Registry, again, using the Docker tag command. You can give the old name and you can specify the new name. Let me give the old name, and I need to get my ACR name for that. / I'll give this name itself. Docker images. You should have. Don't think that there are two images, guys. Here, if you see the image ID remains the same, the size is also the same, but you are having two different images with like the same person is called by two different names. It's that sort of stuff. Same image is now having two different names. Now, if I do a Docker push and I push this over, where is it going? It's going to my Azure Container Registry. Let's quickly verify that. Here you should have repositories on the left. Go and click on it. Yes, my Python app is present and I should have a latest tag. So whenever you're pushing an image, it gets updated over here. Okay, so few commands which I use. Thanks, Praveen, for saying that. Azure account set -- subscription, guys, and give the subscription ID. If you guys are interested in looking into the commands which we executed, let me type history. I did the subscription set. After that, I've just logged into my ACR, giving the ACR name. I've listed the images. I have tagged the images, and then I've pushed the image to my Azure Container Registry. Image is manually pushed. Now, manually deployment also needs to be triggered. So for that, I'll have to go to my Kubernetes service and see if it is up and running. Sorted, everything is up and running, but how do I make my Ubuntu machine to talk to my AKS cluster? Fonts are too small. Okay. Does that make sense now? Your name is so coded, SMBK. Amazing. Okay. Okay. So AKS get credentials is the command, wherein you want to fetch the AKS cluster's credentials so that you can configure this machine to talk to your AKS cluster. Okay, so I'm just executing this. It will give me the options. So I just, either you type --help, or you can just execute it. It will give you, hey, crap, you have done this. Go ahead and execute these commands. So I would pick up from here, --name is the name of my cluster. I think it was AKS demo. And what was the resource group? Resource group is also AKS demo. Let's specify that. And let me pick up this and give AKS demo. When you execute this command, what has happened? A file has got copied from your Azure account to your local machine. Let me show you that file. So from this machine, I can talk to several clusters of Kubernetes. It's not necessary that you just talk to one Kubernetes cluster, right? So whenever you're talking to a Kubernetes cluster, there is a variable called as kubeconfig that gets set, and that cluster's context is picked up and that user's context is picked up. So this file got auto-copied from there. This has the cluster details. This is my cluster's certificate, and I can't see my master, but this is the master wherever it is running in Azure account. And the name of the cluster, there is a context for the user. I'm the administrator for this particular cluster. This is my certificate and this is my client keys. So when I execute a kubectl command, let me clear the screen. If I execute a kubectl get nodes command, it would, oh, amazing. I don't have kubectl because I have never installed. So AZ AKS CLI. Okay. I need to install that. Let me pick up the command AZ AKS CLI install. The package name has to be specified. Install CLI. Oh, too many typos. Yes. Permission is denied. Why? CTL, get notes. Okay. How will it allow? I'm not a sudo user. So a Ubuntu user or a Mamta user in the system is not allowed to download any packages. And that's the reason it was unable to do that. So I just became sudo su. I would go ahead and remain this to be on the safer side. And let me try executing this command. Okay, exit. Now this would work. CLI is installed and context is set for Mamta user. So Mamta can go ahead and execute the command. If I want the root user to execute the command, why it didn't execute as the root user? Because root user's home directory doesn't have that conf file, which we downloaded right now. This AKS credential command, when you execute it, this file which got generated, that is in home Mamta. So Mamta as a user can execute kubectl command. Your root user can't execute that command because root user doesn't have access to do that now. If I copy this file to root user, then certainly, yes, root user can also do. Now, sudo is for super user permission. With sudo, I become a root user. Root user has the permissions to install packages in a system. That's the reason I have done that, Ekansh and Tejaswi, in case you people are puzzled with that. Okay. A normal user in a system can't execute these commands of installing packages. Okay. So I did install of CLI and I have executed kubectl get commands. But before to that, we have to actually execute this so that this gets copied. If this file is not present, kubectl get nodes will give you that 8080 error. Now my cluster is also up. I have an image, but how will I deploy that? So kubectl is the command line interface to talk to a cluster. I should have a YAML file with which I can deploy my application to the cluster. I have written a YAML file, and this is the other section. There are two definitions in the YAML with which we would be deploying our application to the AKS cluster. Okay, so let's understand this file. Okay. Let me save this and let me tell you a little bit about Kubernetes because I'm not sure how many people are aware of it. So in Kubernetes, rather I'll write this way. In Kubernetes, we can deploy an application with the help of a controller called as deployment. Deployment is a controller who has the ability to create containers in the world of Kubernetes would be called as pod. Pod actually has a container running inside it. You can think it's like a wrapper on top of your container. Now this guy would get deployed in the Kubernetes cluster and someone would be sitting and monitoring. And we will tell this deployment that, hey, you got to manage this application and that to 2 replicas of the application or 3 replicas of the application. Then this deployment controller's task is to do that. First thing. So deployment controllers are normally used for highly available and scalable applications, which we want to scale. So this application would get deployed in a container in an AKS cluster, but it would be wrapped up by a pod and it could be controlled by the deployment. If I say 2 replicas, then this deployment's work is to make sure at every point in time, 2 replicas of my Python application is up and running. These applications are again having a private IP address. So what would I do? The containers don't have a public IP address, right? I'll create a static IP address, which would be of having a public IP. And I would expose this to my users. When I give you my link, you people would be accessing this. And this guy would be forwarding the packets to the actual application. So you can think this is like a load balancer. This is Kubernetes service who has the ability to load balance the traffic which is coming across same set of application pods. So this is what we are planning to do. Let's quickly do that. So I'm creating a kind deployment, metadata, the name of the deployment, how many replicas I have. This is my actual pods label, and this is my container specification. I would have to change the name here because my image is not residing over here. My name of the image is something different. So whatever I have pushed, actually, I need to pick up that image. Otherwise, this guy will not be able to pull that image, right? Image residing in ACR has to be provided. So let me quickly go here. Click on this, you will get that entire string. Just copy till here and come back and paste it here. So I'm saying pull this image and deploy a container which will listen on port number 5000. I'm creating a load balancer type of service, which will actually go ahead and create a load balancer in your Azure account. And that load balancer is also listening on port number 5000. So load balancer will receive packet on a public IP address on port number 5000, and it is forwarding the packet to containers port number 5000. That's what we are planning to do. So I'll just write and quit from this file. And command to deploy an application is kubectl create -f and give your definition file. It will create all the resources which are defined in this file. kubectl get all command lists all the resources. Containers are in creating state. Deployment controller is created, which is expecting 2 pods to come up. At present, 0 of them are ready. Execute the command again. Both of them are up and running. Thankfully, nothing went wrong. And I have a load balancer created, but the IP address is still showing pending because it takes a bit of time for my Azure Cloud to give me a load balancer's IP address and that to reflect inside our AKS cluster. Yep, this has come up. So let's go to our portal. App can run without a load balancer service, Achutya, but for that, you will not be able to access the application from outside the cluster. Some applications are meant to talk only within the cluster. Some application needs external exposure. This application of mine needs external connectivity. And that's the reason I have given load balancer type of service. In case you don't need external connectivity, like instead of a Python app, I was deploying MySQL, I would have created service of cluster IP type, a IP address for the service, which is resolvable only within the cluster. What exactly is a service? Because containers don't have a static IP address on which you can reach. If a container restarts, they lose the IP address. We need to provide a static entity for them so that we can connect to it. And that's the reason a concept of service is introduced in Kubernetes. Well, a small session is really difficult to explain each of the concepts. So service is something which is giving us a static endpoint so that I can reach my application. So now I can have a static IP address. Your user is reaching this, correct? You are not going and talking to my pod's IP, and my pod's IP is anyways a private IP address. Every node, Prashant, will have a different subnet range. And in that subnet range, internal subnet range, my pod has received an IP address, correct? And service will get an IP address. You people would have seen that when I selected Azure CNI, there was a range for the service IP. Service IP has got the IP address from there. So here we have created these steps set up. Now, if my pod goes in up and down also, there's no impact. My user is not going to change. Think about it. Millions of servers are serving google.com. Where do we reach? We reach to 8888, right? Does 8888 really exist? We never know. Behind 8888, there could be million servers running. You reach 8888 with saying google.com, and then it routes us to a specific instance of a google.com server, right? It's exactly like that. So manual things have worked really amazing. Now let's go and set up our application to get deployed and created with our Azure DevOps, automate the entire stuff. So building, deploying, both has to be stitched up with our Azure DevOps. That's important. So just to differentiate, this is running inside my application on the server as a container. This is running as a container on my AKS cluster. What is the difference between the kube service we have created and the ones we got while creating cluster in Azure portal? So when we are creating, these are for individual applications. If I have to expose 10 applications, I will have 10 individual service for them. And when we created our cluster, there are two parts in the clusters, guys. One is the data plane, one is the control plane. When Azure accounts master nodes are going to talk to my worker nodes, they also need to come via some load balancer, right? That was that load balancer Tejaswi. So that you can say in a way that it was for the control plane. And if I'm creating one application, I'm creating a service, I'll have a load balancer. If I'm creating 10 such applications, I'll have 10 services and I'll have load balancers for each one of them. Will look clumsy, but we have advanced techniques of reducing that count as well, which we are not covering in this. So manual deployment has succeeded. Let's go here. My code has to reside here. I already have one. I'll not touch that. I'll show you how to create it from scratch. So AKS demo, Python is my project name. So I'm logging to my Azure DevOps with the same credentials, okay? And I'm creating a public project. This guy is troubling me, the StreamYard pop-up. Okay, hit and create. Let the project first create, and then we would host our code in this. So there is a question, can we have multiple applications behind the load balancer? Yes, certainly we can have that, but at present, my load balancer is a layer 4 load balancer, which can route just on IP addresses. If I have intelligent load balancer like layer 7 load balancer, then yes, it can have multiple backends. Like for example, I have ola.com and I have ola.com/corporate, then I can distribute the traffic. For that, my load balancer should be intelligent enough to understand what you have written, which URL you are trying to access. We can certainly do that, but SMVK, for that, it has to be a layer 7 load balancer, which is not there at present. Now, repos is here. I would push my code to Azure Repos. I'll just go and execute this command on my terminal. Let me get this guide on the other side so that it doesn't trouble us much. Yep. So I am executing this. I mentioned that the remote server for this Git repository is that particular link. And the next command is also given over here. I can push everything to my. So I am adding and I'm pushing my code to this Azure Repos. It will ask you for a password. And here you can see the option, generate Git credentials. Copy this and paste it here. In no time, your entire code base is ready here. I have my Azure AKS file, which we have recently updated. I think this guy is showing up the last one, where it is at. I'm just committing all files. Let's see. You can generate that credentials several times, not a problem. Otherwise, save it. Saving is a bit dangerous. Okay, so let's see if my file is reflecting. Yep. So now I have the proper file, AKS demo mj.azure containerregistry.io. The name is correct. Now let's see our actual file. Where is the templates folder? Index.html, saying correct. So all things are sorted. Code is residing here. Now it's time to build our pipeline. Pretty simple. Everything is automated these days. Not much of effort is needed. So just give me 1 second. I'm looking for the one which I had created in the morning so that a different project, and this is a different project. Fine. So my code is residing here. My pipeline section, just hit on create pipeline. In the create pipeline section, you can say my code is residing in Azure Repos. Select the repository. And here it will populate that entire pipeline looking at your code base. So here you can see that I have written a script like this, Azure Pipelines.yaml. For the master branch, for this repository, I am declaring some variables. This is my Docker service connection, the Azure Container Registry's ID it is. It's the resource ID. Image repo name is this, in which I would be pushing. I would be giving the name over here. So I just need to change this guy. Let's do this. For that, I'll have to pick up this particular stuff. I think I had to pick up the entire, I've picked up that. So this is also done. A Docker file exists in this path. That is much true. I would be creating a secret with this. I am using a temporary agent. During build, somewhere the build should happen. We build it on our Docker host machine, but now we are not going to build it on our Docker host machine going further, right? So I would be using agent, call it Microsoft hosted agent, which would be Ubuntu-based machine. And in that, I am building this image. So I am saying that this is stage build. The display name comes here. One particular pipeline can have several stages, and one stage can have several jobs. One job can have several tasks. Sounding very complicated, so just writing it over here. So I would have your Azure pipeline. A pipeline can have multiple stages, like I have a stage build. In this, I can have several jobs, like job 1, job 2. And inside that, I can have several tasks, like to create image, to push image, that sort of stuff. Then I can have a deployment stage in which I can go ahead and pull the image and deploy that to my AKS cluster. So let's see this. So this is the hierarchy. Pipeline will have stages, stages will have job, job will have tasks. Now, we can create separate configurations if you have separate files for it. Like this, you would have separate YAML files, Smita. If you don't have separate YAML files, you would not be able to do that. So you can define multiple stages here And there would be like first you deploy in dev, then you go to QA, then you go to prod. So I will have like that stages. At present, I'm just deploying in one environment. After that, you can expand that by writing few more stages. So here, till here, everything is sorted. I am tagging the image, which I would be creating. I'm saying build and push the image to this repository. Repository name is given on the top where it has to push. And I'm saying this is the Docker files path which you would be building. This is the connection credential you would be using to create or to log into that Azure Container Registry. Let me just check this credential 56636. I suspect this to be of my previous container registry. Let's quickly verify that. No. Okay. I think in my repos, by mistake, this guy was there, and that's the reason it has populated the older stuffs. Just give me 1 second. Okay, I'll do one thing. I would delete this file. Sorry for that, but there's an intention behind deleting it. When you set up a pipeline, actually this guy creates a pipeline. I was just astonished. Yeah. So I want to pick up a task which would help me build, push, and deploy that to a AKS cluster. Let that task get populated automatically. So when you people do it, you would come to the screen. I was not coming to the screen, so I was a bit puzzled why it was so. So now things are looking good. I'll just have a copy of my previous pipeline ready so that I don't make mistake. My resources are residing in this subscription. I'm selecting that. Which cluster in this subscription? AKS demo. I can just remain in existing. I would deploy that in a default namespace. Don't ask me what is a namespace. Can't explain that today. Maybe some other day. The name of the image and the port number on which it would listen. Validate and confirm. This pipeline file should actually get generated. Okay, it has got generated now. It's taking some amount of time, and then we would go ahead and edit it. This time when it comes up right, you would find I don't have to change anything. It has come up with all the correct specifications. Okay, now this looks good. Last time it had picked up the old file. Old file got checked in, and that's the reason. So our task is, these are the variables. These are the variables which we have defined. Few set of variables, which is auto-populated by selecting the subscription, selecting the cluster and all. This agent would be picked up. This service connection of Azure so that I can communicate with my Azure Cloud account from Azure DevOps. And then the build command is there to build the image. This is the build and push tag. It would be building and pushing the image to Azure Container Registry. It would be pushing that with a tag called as $with build ID. I want to tag it with latest as well. So let me write latest tag here, because I would be deploying my application always with the latest tag. Whatever is latest, I would be doing that. Now, the upload part, which you see here, I need to upload the stuffs, but there is a YAML file which I need to publish, which would be picked up during my deployment. AKS file, the Azure AKS file, which we were writing, that file I want to pick up. So for that, here you can see show assistant. Just look for word copy. Copy and publish your artifact. I am not touching this root file. My file name is Azure AKS.yaml. I'll just give that. I'll give the artifact's name as manifest, because bottom it would look for a folder called as manifests. And I'll keep this output. So what am I doing? I'm publishing one image is getting pushed on Azure Container Registry. But from the build pipeline, the code should go to the deployment pipeline. If my Azure AKS YAML file is not going, deployment, it can't execute that file. So we are doing that for this. I got to bring this inside by a few steps. The stars should be aligned. YAML is all about indentation. Now things look good. Yep, it looks good. This is the deployment stage in which I'm deploying. This depends on build. If build succeeds, then only this guy would get triggered. If build is not succeeding, it will not work. First, we are creating a secret. Why a secret is created? Because now what we are planning to do, let's get back our picture once again. Open the recent one. So now, instead of we going and deploying, our Azure DevOps will go and deploy. We have DevOps coming in between. You just don't have now your workstation. You have something else as well. Let's pick up a peppy color for our Azure DevOps. Okay. Now, this would be my Azure DevOps server. Without using scale, if you draw, this is how you draw. Okay. This is your Azure DevOps. Code is residing in repos, which is connected to my code here now. And from here, I have created a pipeline. Pipeline will get a temporary Microsoft hosted agent server. In that, Docker would already be present. This pipeline is saying build the image. So image will get built here. It is saying push the image to this registry. It will push it here. We had manually pushed it. Now my pipeline is pushing. In the second stage, we are saying deploy. Deployment would go this particular, how we executed a kubectl command here to create that kubectl command will now get executed from the agent. Agent needs to go and talk to our AKS cluster to deploy it. What it would execute, it will execute the same command, kubectl create. Now, AKS should be able to pull the image and deploy it. For that, it needs authentication. And that's the reason we are creating this secret. So whatever we did, we would be doing that in an automated fashion. Not our workstation, a temporary Microsoft hosted agent is actually doing that. Let me see how much time. Okay. So here we are all sorted. This is going to create that secret to pull the image. And this guy is actually going to create and push the image, deploy to a cluster. Let me see why this few extra tasks have come in. To be on the safer side, I would just remove them. I'm not creating an in-grace controller, so I'm just removing that. And I'm not doing a host. So the task is coming from a template. Whatever they feel is there in the template, everything is getting populated. Whichever things you don't need, just go ahead and delete that. So here it is going to deploy this particular application. And you can see from this container registry, from this image repository, a tag would be picked up and it will deploy. Deployment things are also given. The secret which we are creating is used here. Things are looking cool. Let me just quickly verify all the things once again. So now time to save. And let's run the pipeline. Hopefully it succeeds. And it doesn't crash in the demo. So Let's wait for an agent to be grabbed. Meantime, here, an agent would be grabbed on the fly, which would have Docker and everything configured so that it can build our Docker image and push that. So build of Docker image is under progress. How we had built the Docker file, this guy is going to build the Docker file. See this. It is building that Docker file step to step. Image would be produced and it would be pushed. After the image is pushed, it will go to the next stage, like the deploy stage. Someone was asking about the dev, QA, and all right. I think it was Smita, if I'm not wrong. So, Smita, you should have more stages. Deploy stage to dev, deploy stage to QA, deploy stage to prod in such cases. We would be sharing the files, don't worry. Rohit will get that sent to you people. The entire repository is open sourced, so you should get that. I can even put that in the GitHub as well, and you should have it. So building and pushing of image is successful. That's the reason you're seeing star. Let's see, deployment should succeed. Let me go to my Azure Container Registry and see whether image is being pushed or not. One we had pushed manually. Now, I think this is the one which is pushed by us some time back. And this is the one which is pushed by, sorry, I went one step back. Where is it? Yeah. There are two repositories, one which we pushed manually and one which we have pushed in an automated fashion. This guy is pushing all the images with two tags. One tag is 465 is the build number, and latest tag is the tag which we have pushed. It has failed. It says I can't find the manifest. Where is that guy? Why didn't it find it? Let's see. You can go and find what is published in the artifact. See whether your Azure AKS is not published or we didn't give the path proper. Is this not the correct file? Okay. We have done a very silly mistake, which I'll right away correct here. What mistake we have done is our image name is not the latest image which we are producing. Okay. Let me go to the pipeline once again, edit it and see what exactly has gone wrong. We should have picked up this because this is the image repo name. We didn't write that. That we would rectify. And it is unable to find the manifest file it is saying. It is saying that whatever you have published, in that I'm unable to locate this file. So we have published manifest. And let me check that. Manifest bundle. It is picking up from that place. Okay, yes, this is not correct. From where do I pick the file for deploying? That is not correct. So we actually need to deploy that with here. We are publishing that in the pipelines workspace with the name manifest, and this is the file which has to be picked up. And that's the reason it couldn't find it. I think now it should work. So I'll do one more thing. I'll save this. It would trigger a pipeline. I would cancel that because I need to change something in the repository as well. This name is not correct. Let's edit that. Actually, we should edit that in our server and come back here, but I'm doing it directly over here. Now let's see. Build will pass. Deployment is a problem for us. It couldn't find the manifest. Understand that the build pipeline and the deployment pipeline are two different things. When I produced the image got pushed here, but I need my YAML file with which I would be executing my deployment stage. So in this deployment stage, I need to copy my AKS file over here, then only it can go ahead and execute that kubectl create command, right? So that file it was unable to locate, but because from where we were picking up was not the correct path. It was the default path. We published that in our pipeline in manifest folder. I'll just quickly show you what change I've done so that. So we were publishing that particular thing. You can see I'm saying the content would be AKS YAML. The artifact name would be manifest, and it would be publishing that in this pipeline itself. But when I was picking up, I was not picking up from the correct place, and that's the reason it couldn't find that YAML file. Whenever you publish in a pipeline, in the previous run, you can go and check here. Published artifacts would be showing. And YAML file was present, but that guy was unable to pick up. And that's the reason I went ahead and looked into that. Now, download of the artifact is done. Creating of the image is being done. It is able to successfully pull the image. Now it's going ahead and deploying it. Let's see the deployment succeeds or not. So this is the time when it will go ahead and do that kubectl create command. It is doing that. You can see here. It has checked. It will verify whether it is able to reach our load balancer's IP address, and then it will go ahead and mark this as green. So it has successfully completed both the stages. Both are done. This guy is having one artifact produced. It is showing. This guy is just doing the deployment. Now let's go back to our terminal and see that we are able to access our application. Now when you do kubectl get all, the older version is terminated, the newer version is coming up. And this is the IP address. So older version, we had deployed it manually. Newer version is the one which we have deployed it in an automated fashion. So here, if I go to my web browser, I think it is over here. Go with port number 5000. You should be able to access the application. So this has been served from my Kubernetes cluster, and it is deployed in an automated fashion. So you can give this link on the chat, Rohit. If you can give, people can access my application. First, IP address with port number 80 will give you the one which is for your, sorry, I have written 500. Can you write 5000, please, instead of 500? So you can reach my application at 20728966:5000. Yeah. And you people are not able to access my repository. Is that so? Then let me quickly do one thing for you people. So any questions? Deployment has also succeeded. Are we all good? So that was the agenda. It's done. Any questions? If we have VM and AKS are in the same VNet? No, not at all. It's not necessary as well, Vijay. VM is in different subnet. Your AKS is in a different subnet. Doesn't matter. Two machines residing in different networks can also talk to each other, right? So they can. Let me quickly do one thing. Let me download a zip on my local machine. Rohit, if you're there, these comments are not getting updated. It just says new comment, and I'm not able to see if there are any questions. If you mind reading that for me.
Yes.
It says new
So
comments. I'm unable to click on that. I'm sorry.
the last comment was from Registry. So let me show it on screen. Just confirming if you have already answered this question.
What was the upload stage in pipeline prior? You had edited. What was the upload stage in pipeline? Upload stage, I have not changed, Tejasvi. So the upload was not uploading the artifact in the pipeline. It was expecting me to create a file share and share the AKS file. So what I did, I said that it would be just doing, publishing that artifact in the pipeline itself. That change I had done. Any other question? What is the CI output published? CI output published is the output of my artifact. Unpublishing is the ACR's build image. And second, what we have published is just copied the AKS file so that it is available to our deployment pipeline. Nothing more than that.
So there is a query by Vijaya.
This I have answered, that both of them are in different VNet. That doesn't make any difference though.
All right. I think then we don't have any more queries.
They wanted the code, so I just put that in GitHub. Hopefully it's fine if I share my GitHub link.
Yes.
Yeah, right? Okay. Hopefully people like the session. I'm not sure if you guys have got it, not got it.
That was a really nice session, actually, Mamta. And the way you explained using those whiteboard, that really helps. So there are a few questions, Mamta, by the way. So I'll just present.
Yeah. Yeah. What's the question? Where I can see in DevOps, what you can see, is it that the complete question, or Smita has
Yeah,
asked something else before that?
exactly this. But
Okay.
continue.
Now it's refreshing. Oh, teri. I can't see that window, huh? So Smita says, where can I see in DevOps the build agent? You can't see, Smita, the DevOps build agent because it's a temporary Microsoft hosted agent which has been given just for temporary time. So that server is given to you for some time till the time your build gets executed. So if you go ahead and look at the pipeline, I'll send that code repository from Rohit. Rohit would share that. Let me show this. So this pipeline is asking for an Ubuntu agent, right? Wherever you saw, we use this VM image. So this VM image is asking for a Ubuntu based agent. And if you go to any of the runs, you would find that whenever this got executed, the first task here before to this, it was actually going and grabbing a hosted agent. Can you see that it is going to Azure Pipelines pool asking for a Ubuntu latest agent, which is nothing but a Microsoft hosted agent. And this guy is like, Azure has given me a temporary server in which I have done a Docker, like what we did manually initially. We did a Docker build, Docker tag, Docker push. All the three things happened on this server. And this server has my Azure CLI. This server, second deploy server, has my kubectl, and it is able to execute on my behalf the kubectl create command and pull the image and deploy it in my AKS cluster. So there are two agents here. One agent is building, one agent is deploying. Okay. The secret file is needed when AKS goes and talks to ACR to pull the image, because AKS needs to authenticate to ACR. ACR will just not like that give the image to anyone and everyone, right? When I'm also doing a Docker pull, it is asking me to enter the credentials. So imagine that your actual images are being pulled on the worker nodes. I would have an AKS cluster. Your worker node would actually go and execute the kubelet residing on the worker node, gives instructions to the Docker, and Docker on this machine goes and talks to your ACR and does a Docker pull. Then the image comes here, and then the container gets created and it gets wrapped up by the pod. So we feel pod is created, but actually the instructions are being given to Docker to create the container. For that, it needs to pull the image. So at this point, secret is utilized so that this guy can go and talk to my ACR and pull the image. If it doesn't have authentication, it can't do. So scaling setup in the pipeline addition can be done from here. Scaling is actually can be done from here. You just increase the number of replicas the application instances would scale. Like, for example, if you do kubectl get all, you would find there are two instances of my deployment pods running. I can go ahead and execute. This is manual scaling. For automated scaling, I'll have to create one more controller called as horizontal pod autoscaler. Kubectl scale deployment. I'll just pick from here. I would scale this deployment. How many replicas you want, you can give. Deployment supports scaling, but it supports only manual scaling. If I want to create auto scaling, I would have to create a horizontal pod autoscaler component as well. So I have scaled now to 5 replicas. You would find that now controller is making sure that 5 of the replicas would be running at every point in time. Okay, so this is for the scaling part. Rohan is asking Azure AD authentication advantage over RBAC. Azure AD authentication would be used for users authentication to the cluster. RBAC would be used for authorization purpose. Azure AD is an authentication tool. I can authenticate you and I can say, hey, say for example, Rohit has a key associated to it. If Rohit logs in, Rohit is a valid user in the cluster. That is one thing. But what is supposed, what all actions Rohit is supposed to do in the cluster would be defined by the RBAC. RBAC will say that Rohit is a developer. Developer can only create, they can't delete. That sort of thing. So they will work in combination, Rohan. Gyan is saying, what is replica set and replication controllers? What's the difference between them? Replication controllers are different. They are older way of creating replicas. Replica sets are a newer version of creating it. It helps us in doing blue, green, and canary deployment. You can see here, when I deployed my new version of it, one new replica set got created. And my deployment, when it gets created, it actually has a replica set created internally, and this has the pods running under it. If I'm deploying version 1, this replica set makes sure that both the pods are of version 1. When you are upgrading your image name to say version 2 in your YAML file, or new build happened and version became changed or version became version 2, then this is my blue deployment. Now I'll go ahead and deploy my green deployment. That would happen from here. One sec, I'm unable to see my mouse cursor. Okay, so it would create another replica set, which would be RS2, and newer pods would run inside this. It would not be deployed under that. And this would get deleted. So slowly new version of replicas will come up and old version of replicas would get terminated. Remember, I mentioned that one version we deployed manually, and when we deployed it in automated fashion, it was showing terminating. And that's the reason the older ones got terminated. But this guy is retained. If I want to go back to the previous version, I can quickly go to the previous version. So replica sets help us in replicating in sets. That's the advantage of it. Aqua is used for vulnerability scanning. That's one of the good tools. Anchor is used for vulnerability scanning. We can even use that. Variable groups can be created for each of the environments. Yes, that can be done, and that can be incorporated in our pipeline so that we can supply those variables on different environment levels. Awesome. Yes, Yogananda and Smita, both are correct. I can even set up my nodes in a different cluster and in different clouds in our local system anywhere. Azure DevOps helps me in deploying, just not to Azure, but to any other cloud or on-prem environment as well. Amol's answer is correct. If pod is going down, then kubelet will go and inform that to the API server. API server will go and update that in etcd. Because etcd gets updated, your controller comes into picture, and controller understands that the desired state is 5 now, in my case, and would quickly go and bring that back into action. So self-healing process would get triggered. Deployment group in Azure pipeline is normally used if I have a set of virtual machines which are there, which are configured as a deployment servers. That time we configure the deployment group. In case of AKS, we don't use that because our deployment is not on a VM. Otherwise, if we would have taken 3 VMs and we would have deployed, we would have created a deployment group out of it and would have deployed into that. So let's see the time. Okay, we have overshooted by 15 minutes. Hopefully, people are not cursing for that. Yes, Shubham, for scaling on the fly, based on the load, you need to create another component called as horizontal pod autoscaler. Gyan stateless is for applications which doesn't remember, not remember what it has done. In the past, stateful are like database type of application. They got to remember a lot of sessions and all that stuff. Our front-end applications are stateless. Our back-end database applications are stateful. You can think in that terms. I think, Rohit, we are good. We have shooted by 15 minutes as well. If people are happy and we are good with it. Facebook is just not a single application, Yogananda. Facebook would have been made with some 170, 180 microservices. One of the microservice is a database which is keeping our data, and that is stateful. So a Netflix or a Amazon type of applications are made up of 170 microservices. We just created one microservice and deployed one. So architecture is pretty more complicated than we are imagining, actually. Great. Thanks a lot, guys. Thanks a lot for attending, and thanks a lot for making that session so interactive. Hope you people enjoyed it. Rohit, over to you.
Thank you so much, Pamela, for joining us today. And this was definitely a very interactive session. And the way you presented, and we have seen so many comments, the comment box as well. So
Yeah.
people were very interactive, and yeah, like you answered all the questions actually. So it was from end to end, as you mentioned before starting the session. And I hope everybody learned like what they have uh, come and actually intended to attend today's event. So yeah, we'll also look forward to attending more events by you, Mamta. So
Sure.
people,
So,
to just mention you about Mamta, so she's a co-founder for Tech Scalable as well, and they do several sessions and workshops on
so
Azure.
we are
So
Microsoft training partners ourselves. We do training and we do consulting. We do quite a few number of stuffs. We work on machine learning, AI, and DevOps. That's our forte of work. We work on those stuffs.
so if you're looking for getting certified on Azure, then Mamta is the go-to person. And yeah, their workshops are really helpful. They are very intensive, and they start from basic, and like I think that those are around 7 to 8 hours of workshop, right, Mamta?
No, paid programs for certifications are 5 days workshops normally. So that span across 5 weekends for individuals. We normally on the weekdays we do for the corporates, and for the individuals we do through the weekend. So whoever is interested to know more, you can connect with me on LinkedIn. You can look for Mamta Jha. Events are also been there. Confab events have tagged me in. So if you can connect with us, certainly batches are coming up. I have a Azure DevOps batch coming in the month of August itself. So if you people are interested, I would be the instructor for the session. So certainly we can get you guys in.
Thank you so much, Mamta, for joining us today, and we'll also
Great.
try to have you in our future. I know, like your calendar is most of the time very booked, so we'll try to catch hold of you.
Sure, sure. If you want to do a series as well, that would make more sense so that people can
Yes,
continue for multiple sets. Rohit, I'll pass you on my code base. If you can put
yes,
that for others, that would be really helpful.
yes. We'll mention that in our post-event mailer, and we'll also mention other things as well.
Yeah, great. Thanks so
Thank you so
much.
much, Mamta. Thank you.
Thank you. Thank you, everyone. Please take care and stay safe.
All right. So, guys, that was Mamta, and we hope you enjoyed the session. So, we also have our future events lined up. So, check out our website, which is easydev.convo.com. And if you have any queries related to this session, do drop in your questions in the comment box. Mamta will also try to answer them offline. Thank you so much for joining us today, and have a great weekend ahead, and be safe. Thank you all.